Hi everyone. I am going to solve today in this video the mostly incorrect answered questions in TESTBANK, test 1, test 2 and test 3, which is about the section 1. The first question is 1 revolution is equal to how many radian? This is the first question, which is mostly incorrect answered. 1 revolution means the object will start from one point and come back to the same point again. So this is one revolution, and this one revolution is equal to 360 degrees, but it's in degree. It's 360. This is 360, however. So answer must be in radian. This is not correct for that reason. Second one is 2 pi radian. Yes, 1 revolution is equal to 2 pi radian. This is correct. And also pi is 3.14. 2 times 3.14. 2 times 3.14, which is equal to 6.28. This is also correct. So that's why both B and C are correct. Choice must be both B and C and D. Some students answered B, some students answered C. So both are correct, but which one is also includes B and C? D. You should read all the choices to answer the question correctly. Next one is question number 4. What is the arc length for 1 revolution? We know that 1 revolution is this, so one length of the circle. So arc length of the circle, which is the circumference, is going to be, so arc length for 1 revolution, and the circumference is calculated by 2 pi r. So that's why arc length for 1 revolution is going to be 2 pi r. And question number 15 is the next one. What is the angular displacement for 3 full turns? So we are going to convert turn to radian. Turn means revolution, 3-fold revolution or 3-full rotation. So we will convert revolution to radian. We know that angular displacement in radian. So every 1 revolution is equal to 6.28. So that's why we should multiply revolution by 6.28 or 2 pi. So answer is given to according to pi. That's why better to write it 2 pi. So three full turns means 3 revolutions. Turn means revolution. So that's why angular displacement in radian is going to be delta theta in revolutions 3 multiplied by 2 pi, which is equal to 6 pi radian. 6 pi radian. So choice B is the correct answer. And next question is 10. How long does it take for second hand of the clock to complete 1 revolution? Second hand counts the seconds, and 1 revolution or 1 rotation of the second hand is equal to 60 seconds. 60 seconds. How long does it take for minute hand of a clock to complete 1 revolution? Minute hand completes 1 revolution in 60 minutes. So, but answer must be written in second. So we should convert this 60 minutes into second. We know that 1 minute is equal to 60 seconds, but minute hands 1 revolution is 60 minutes. So you are going to say 60 minutes is equal to how many seconds? So cross product x is equal to 60 times 60, which is going to be 3,600 seconds. So answer is D. These are mostly incorrect answered questions in test 1. And test 2, question number 10 is another one. How long does it take the minute hand of a clock to move through 4 radian? We know that one rotation of the minute hand is rotation of minute takes 60 minutes. We know minute hand 60 minutes 1 rotation takes. So which means 1 rotation is equal to an angular displacement 6.28 radian. So 6.28 radian takes, so convert 60 minutes into second. 60 times 60, which is 3,600 seconds, because we should multiply 1 minute by 60 seconds. So if we multiply them, it's going to be 3,600 seconds. So then we are going to say that 6.28 radian takes 60 seconds. 4 radian takes how many seconds? We will get that again, cross product. X multiplied by 6.28 is equal to 4 multiplied by 3,600. Simplify 6.28 by dividing both sides of the equation 6.28. So it's going to be answer. Let's check it. 4 multiplied by 3,600 divided by 6.28, which is equal to 22,293. 2,293 seconds. So C is the correct answer. And 11, find the average angular speed of Earth about its own axis. So Earth is revolving about its own axis. So we will calculate this angular speed in radian per second. So hint, Earth orbits about its own axis once. Not orbit, this is normal, must be rotate. It's typing. Earth rotates about its own axis once every day. So we are going to say that angular displacement for round rotation is delta theta is 6.28 radian, and time for one rotation is 24 hours. So 1 day about its own axis. So but this hour must be converted to second in calculation, because in the choices the speed is given in radian per second. Omega average is equal to delta theta over delta t. Delta theta is 6.28 radian. It's okay, but delta t is 24 hour. So we should convert hour to seconds. 1 hour is 60 minutes. So we should multiply 24 hour by 60 to convert to minute. And 1 minute is 60 seconds. So we should convert minute to second by multiplying once again 60. So by this multiplication, we will convert hour to second. Now we calculate them all. 6.28 divided by bracket. Without bracket also it's possible. In my calculator there is no bracket. So divided by 24 equals divided by 3,600. So it is 7.26, almost 7.3. 7.3 times 10 to the power of -5 is the correct answer, radian per second, for this question 11. And question number 4, what is the angular speed of the second hand of the clock in radian per second? We know that one rotation, always we are going to think one rotation. In here we taught one rotation, in here we will talk one rotation for calculating the speed. So one rotation takes 60 seconds. So one rotation of the rotation takes 60 seconds for second hand of the clock. So one rotation has an angular displacement 6.28 radian. This is delta theta. So but negative. Delta t is 60 seconds. So omega average is going to be delta theta over delta t. Delta theta negative 6.28, which is one rotation, divided by delta t for second hand is 60 seconds. So if we divide them, we will get the answer negative 0.1 radian per second, which is B. Negative because clock turns clockwise. So for clockwise rotation, so we get both delta theta and omega as negative. What is the angular speed of the minute hand of the clock in radian per second? Again, we will use the same logic. One rotation for minute hand, one rotation takes 60 minutes, but 60 minutes is equal to 3,600 seconds. We will multiply 60 by 60 to get the time for one rotation of the minute hand. So, and one rotation, again, angular displacement is negative 6.28 radian. Delta t is 3600 seconds for minute hand. Omega average, again, delta theta over delta t. So, negative 6.28 divided by 3600. So let's divide them. 6.28 divided by 3600, it's going to be 1.74. 1.74 negative 1.74 times 10 to the power of negative 3. Yeah, radian per second. So it is A. And question number 16. A cyclist rides along a circular track. If the cyclist travels around exactly half the track means half revolution, 1/2 revolutions. So in 3 pi second, which is delta t, what is average angular speed? Question is omega average. So 1/2 revolution is which initially must be converted to radian. So angular displacement in radian is equal to 1/2 revolution multiplied by every revolution 6.28, which is going to be 3.14 radian. And delta t is given by the time it's pi, because delta t is given in pi. That's why better to write angular displacement in pi as well. So 3.14, which is pi radian. Delta t is given in the question as 3 pi seconds. So omega average is equal to delta theta over delta t, which is delta theta is pi radian and delta t 3 pi. So simplify pi, 1/3 radian per second is the correct answer for this question. And question number 20 is a ministry exam question of 2020. The angle that the second hand of the clock rotates in 10 seconds is how much? What is the angle? So we know that second hand of the clock, one rotation takes 60 seconds, and we know that one rotation is in degree because choices are given in degree. That's why we should write it in degree. One rotation is 3,600 seconds, 360 seconds. Takes 360 degrees takes 60 seconds. But question is, in 10 seconds, it takes how much? So again, cross product, x multiplied by 60 is equal to 360 multiplied by 10 divided by 60 divided by 60. So this division is 6 multiplied by 10, which is 60 degrees. So 60 degree choice is C for this question. And for test 3, there are 4 questions which are mostly incorrect answered. One of them is question number 9. The tube within a washer goes into its spin cycle starting from rest. Starting from rest means initial angular speed is a 0 and reaching an angular speed of 11 pi radian. So 11 pi radian is the omega final in 8 seconds. So delta t. How many revolutions? Questions delta theta in here in revolution does the tube turn. So we are going to use the second kinematic equation, 1/2 omega initial plus omega final multiplied by delta t. So 1/2 omega initial is starting from rest 0, omega final 11 pi multiplied by delta t 8 seconds. So 8 divided by 2, which is 4. 4 multiplied by 11 pi, which is 44 pi radian. This is 44 pi radian, but questions about revolutions. We can convert radian to revolution by delta theta in radian divided by 2 pi. So 44 pi divided by 2 pi. Simplify pi's. 44 divided by 2, 22 revolutions is correct answer. And question number 8, a Ferris wheel initially at rest. Initially at rest means which is omega initial is a 0. So accelerates to a final angular speed. This is final angular speed, omega final. And rotates to an angular displacement. This is delta theta. Delta theta. What is the Ferris wheel's angular acceleration? Calculate alpha. So there is no time interval given in this question. If time interval is not given, so we are going to use the fourth kinematic equation, which is omega final squared is equal to omega initial squared plus 2 alpha delta theta. So omega final is 0.7 squared. Omega initial is 0. So plus 2 alpha is the question. Delta theta 4.9. So 0.7 squared is 0.49 equals 2 times 4.9. It is almost 9.8 alpha. Divide both sides by 9.8. Divide 9.8 for simplification. So let's divide it. 0.49 divided by 9.8, it's going to be 0.05. Alpha is equal to 0.05 radian per second squared, which is B is the correct answer. And question number 4 is the next one. If an object has an angular acceleration of 10 radian per second squared, so here the number is positive, angular speed of the object will do which of the following? We know that alpha is equal to omega final minus omega initial divided by delta t. If alpha positive, which means omega final must be more than omega initial. So this number in this will be positive, so result will be positive. So if omega final is greater than omega initial, which means speeding up or increasing, angular speed increases. If positive, angular speed increases. So choice is A. But if answer were negative, so in this case decreases, you are going to say. If angular acceleration is 0, answer will be remains the same. And question number 7. A car is traveling at 30 meters per second and undergoes a constant negative acceleration of magnitude 2 meters per second squared when the brakes are applied. So this is given and the linear values are given. This is initial linear speed, undergoes a constant negative acceleration of magnitude 2 meters per second squared. This is A, but it is negative 2 because it says negative in the question. Negative 2 meters per second squared. How many revolutions does each tire make? So how many revolutions is delta theta question is this. Does each tire make before car comes to stop? Comes to stop means final speed must be equal to 0. Assuming that the car does not skid and the tires have the radii of 30 centimeters. So R is 0.3 meters. In here, also there is no time interval given. That's why we are going to use for equation. But linear form, linear data is given in this equation. First, we should calculate delta S by using the linear equation omega v final squared is equal to v initial squared plus 2a delta S. So after that, by using this delta S, we can calculate delta theta. Final speed is 0 because it stops. Initial is 30, what square of 30, plus 2 multiplied by a negative 2 multiplied by delta S. So 0 is equal to, this is 900, minus 2 times 2, 4 delta S. Get this negative delta S in on the left side. 4 times delta S is equal to 900. So divide by 4, simplify. So delta S is going to be 225 meters. Delta S, distance traveled by the car. And also this is the arc length rolled by the each tire. So if the arc length is given, so we can calculate angular displacement delta theta by delta S over R. Delta S, we calculated 225. R is 0.3. This division will be 750 radians. Still we didn't get didn't finish the solution because choices are given in revolution. We should convert it into revolution. Angular displacement in revolution is equal to angular displacement in radian divided by 6.28. So 750 radian divided by 6.28, which is 119 revolutions. Choice C is the correct answer for this question. So this is all for this test 1, test 2, test 3, which is the mostly incorrect answered questions. So I will continue doing them for the next section 2. But first you have to enter the answers to the zip grade according to the statistics of the test. I am going to prepare one more video about the section 2. Take care. See you later.